For joining me on this lovely day to introduce the new HOBO UX120-018 plug load logger. My name is Herman Gustafson. I'm a product marketing engineer at Onset. I was involved in development of this product. I've been at Onset now for about 10 years, worked in a few different departments. I worked in sales for a while and technical support, and now I'm in product marketing helping to develop new products. So our agenda today will include a little history of Onset. We're going to talk a little bit about what we're going to cover in the webinar. We're going to introduce the UX120-018, the plug load logger. Talk about its key features, and we're also going to touch on the entire UX product line as well. So who is Onset? Well, we consider ourselves the leader in portable data logger and data logger technology. We were founded in 1981. We have approximately 130 employees. Everything is designed and manufactured in Bourne, Massachusetts. And the little map there, we're right at the beginning of Cape Cod, a little red area there, about 60 miles south of Boston. And to date, we've sold probably more like 2.5 million HOBO data loggers. So details of the webinar, it's going to run for about 45 minutes or so, plus or minus. Please, if you have any questions, type them into the question sections of the control panel. I will have I won't be doing them, I won't be answering them live, but at the end of the presentation, I'll read through some of the questions and see what I can answer for you. If we run out of time, we can always respond to you via email as well, because we will get those recorded. The webinar is being recorded so that you will be able to review it if you need to, and there is a webinar evaluation we'd like to have you complete when we're done here. So, introducing the UX120-018 HOBO plug load logger. It's the latest product in our next generation USB product line. The reason we say it's next generation is we had we had the old U12s, the U10s, and those were basically blind loggers, no displays. This is another in the line of the new UX products, or the next generation product. The initial configuration is only for North American outlet and voltage, which again is supported by the US, Canada, Mexico, and a few other countries, and I'll have a list of those for you later. And we're going to talk a little bit in later slides about why we decided to do this first, but we'll go through that. Right now, it's just a North American outlet and voltage configuration. Again, the software it's compatible with HOBOware Pro and HOBOware Lite for both Windows and Mac. And it will require you to upgrade to version 3.7 or higher. Right now, 3.7.0 is available on our website as a free download. And the device is really, it's designed for a wide variety of applications. Pretty much anything that you can plug in to a 120 type outlet, you can monitor with the plug load logger up to 15 amps maximum, or 1800 watts. Some of the applications that we developed this for, specifically for office space energy auditing. A lot of folks, energy auditors, they're interested in determining individual workspace energy consumption, both prior to putting in energy savings steps, like using smart power strips, and then after the implementation to quantify their energy savings. So that would be a common application. Another thing that people do, and again, sometimes this is wrapped into the office space energy auditing, is to have a look at office space energy consumption versus the occupancy of that space. So that would be, you would combine occupancy data with plug load data from the same space to get an idea of what the energy consumption is when the area is occupied versus not. good product for monitoring vending machines. One of the other things too is, again, we developed this product specifically for our higher end energy auditing customers. So consoles, and this would be a very good product for monitoring those as well, like the PlayStations and Xboxes and things like that. So some key features of the UX120-018. The list price is $239. We do have some quantity discounts available for those as well. We're offering 6 native measurements from this device. We're measuring true RMS current and voltage. We give you active power in watts, active energy in watt hours, apparent power in volt amps, and power factor. We're actually using a power quality chip from Analog Devices in this unit. The chip itself would do a whole lot more than what we're using it for, but these are the measurements we're taking out of it for this specific device. Again, we're really shooting to get the most features for the lowest cost possible. So that's kind of where we came from with our decisions. The voltage range, again, 120. It's designed and calibrated for 120 volts AC nominal, plus or minus 15%. It will handle 50 hertz, but typically these are 60 hertz applications. And the outlet in the end is a standard NEMA 515 configuration. The range of its measurements in amps is, with a unity power factor of 1, we can read down to basically 1 watt, which gives you 8.3 milliamps, up to 15 amps max, or a maximum load of 1800 watts. And again, minimum power resolution is 1 watt. The chip itself will resolve better than that, but this is the stated resolution. It's down to 1 watt. Our accuracy, we were really shooting to get a 0.5% across the range. Unfortunately, there is some self-heating up above 14 amps. So the resistors that are in there and the components in there that's doing the sensing, they could heat up above 14 amps, and it could go a little beyond a 0.5%. So what we're saying is a 0.5% to 14 amps, and then 1% above 14 amps if you have a 100% duty cycle. So, and it's plus or minus 0.02 for power factor. The device can, those inputs can drift in the first year due to the way that those components age. Just in the first year, up to 0.5% as well. So worst case is you're going to see about 1.5%. The device is calibrated at the office. It's calibrated using a very expensive set of equipment, and the device that we're comparing it to is calibrated to the ANSI C1220 0.5% standard. Again, it has an LCD display. So you can get real-time information. The LCD has a Lexan window over it, so it's very rugged. It's pretty much step on it. Well, depending on how much you weigh, you could step on it and not damage it. Unlike our other UX120 products, this particular device has a 1-second LCD refresh rate. The other ones are 15 seconds. One of the interesting features of this product is it has what we call meter mode. Meter mode, the way this works is when you plug the logger into an outlet and plug a load into it, it will immediately start displaying all the measured variables on the LCD. It won't be logging anything until it's actually launched in HOBOware, but it does give you the ability to view live data or live meter data without having to do anything, without having to launch it or anything with software. It'd be a really good tool for just doing like spot checks on different types of equipment. It will support up to 1.4 million measurements. That equates to 4 megabytes of memory, just like our other products. The reason it's not 1.9 million is because this is 24-bit resolution, where the other ones I believe are 16. Another interesting point about this product is it's got two AAA batteries in it, and so what that means is that it gives you the ability to configure the logger without it being plugged into an outlet. It's not line powered until it's actually plugged into the wall. Once it's plugged in, the batteries are taken out of the circuit and it runs off the AC line. One of the issues that people had with one of the competitors' products that does similar functionality to this product is that it was 100% line powered. So if they lost line voltage or if there was a spike or something on the line, they would lose data or their data would be corrupted. That will not happen with this product. We like to say it's line powered with battery backup. My engineers say it's battery powered with line backup. But anyway, the whole idea behind the battery is to make sure that your data never gets corrupted. It keeps your data intact. The battery life, when you're using the logger plugged into the wall, the batteries will last you a couple of years, probably longer, but we're being conservative with that estimate. They are user replaceable. There is not a door on the back of this thing. You have to actually take it apart, and that's because of some certifications that we needed to go through for safety. A question came up the other day from someone about why didn't we use rechargeable batteries in these. The idea behind this product is to keep cost as low as possible. Rechargeable battery circuitry would add more cost, which we didn't have the overhead for. So we're just using standard alkalins. And again, they should give you plenty of battery life for your applications. This device does have the ability to log minimum, maximum, and average statistical parameters as well. If you want to select those, we're not doing standard deviation like we do with some of the other products. The other thing about min, max, and average, and I'm going to talk a little bit about this later, but the statistics are based on a fixed sampling interval of one cycle, or 16.67 milliseconds. That's not user selectable. So we'll talk about that in a few minutes. And again, it's a very rugged case. It's got a Lexan protective cover over the LCD, so it can't be broken. Unless you hit it with a hammer, perhaps, I don't know. And it comes with a 3-foot or 0.9 meter AC line cord. So a common question for us, why just a North American configuration out of the gate? Well, it has to do with our aggressive development schedule. It also has to do with keeping costs down initially. This product was developed very quickly and brought to market very, very quickly. To meet a specific need for a specific set of customers, and it was not feasible to incorporate multiple outlet and voltage variations in the time allotted. That being said, moving forward, we are going to be looking for input from our customers, from you, and from our international distribution network as to the viability and interest in this product in their specific regions, and so that we can make an informed decision as to which additional international configurations that should be added. I think right now it goes without saying that we're going to come up with an international configuration. It's just a matter of how we're going to implement that. It is going to be a different product because we do have to put some different components inside. If you do have any questions about this product in respect to where you live and where you're going to be using it, please give us a call or contact our salespeople just to talk about it, because we want to make sure that you get the right product for the right application, of course. So here's our logger. We're just to do a quick tour of the outside of the device. Here's our LCD display with our protective Lexan window glued in. We have a start-stop push button, very similar to our other UX products. That's where the AC input goes. The line cord, again, is included. We have a next clear push button here that will allow you to scroll through the different screens, and we're going to go through how those screens are displayed here in a minute. There's an standard NEMA 515 outlet on that end of the logger, and there's a standard USB 2.0 jack on the bottom. On the LCD itself, you get your standard HOBO battery level indication, and you also get your memory used status bar and a wrap an indication if it has wrapped as well. So here's a little, this is an animation that we did. There's where your line cord connects. There's the back of the logger. There's the top with the, there's little nubs in there so you can stack them on top of each other. There's your NEMA 515 jack. And there's your USB port. So a little description of the next/clear push button functions in logging versus meter mode. Okay, so there's the next clear push button. So when you're in meter mode, in other words, if you're not launched with HOBOware, if you just have it plugged into the outlet, you would push and hold the next clear push button for 3 seconds to reset the accumulated watt hours to 0. You can see in that screen, this is the main screen, you see voltage in the upper left, current in amps in the upper right, power, watts in the lower left, and then watt hours, which is accumulated energy consumption, in the lower right. When you're in meter mode and you're not launched in HOBOware, that watt hours number continuously increments as it's counting up how much energy is being consumed by the load. If you push and hold the next or clear button, press and hold it for 3 seconds, in meter mode it'll reset that number back to 0. When you're in logging mode, in other words, when you launch the logger in HOBOware and tell it to start logging, you use the next clear push button to reset the minimum maximum statistics that are displayed on the LCD back to 0 until the next screen refresh. We'll talk a little bit more about that. But basically, what happens is when you launch the logger with statistics available, you go to one of the statistics pages, and we're going to show you what that looks like in a minute, and you will see for maximum, say, you'll see the maximum, and it's a static number. It'll say the maximum either voltage, current, or whatever parameters you selected are displayed until the next another higher number is detected, and then that's changed. If you want to reset those so that it looks for the next highest one, you press and hold that next clear button for 3 seconds. When in your logging mode, if you reset the LCD, if you reset the min or max statistics, it doesn't affect the log data at all. And also, it doesn't, min-max statistics are displayed as the min-max values detected since the logger was launched. So that's, when you launch the logger, it immediately starts looking for the minimum, maximum, and it displays those. And if you press the next and clear button and hold it, it'll reset it until the next highest one is displayed or detected. Something else that's we want to discuss just briefly is displayed versus logged energy consumption, or watt hours, or kilowatt hours, if you will. So when you're logging data, the displayed watt hours will increment for the duration of the deployment. So in other words, as you're logging data, your LCD will increase. You'll see your watt hours increase incrementally until you actually read the data out and stop the logger. In the data set itself, it shows the log data as the total amount of energy consumed per interval. And that gives you the ability to apply a filter based on a specific time period in your data set. So you can say, what's my total energy consumption per day, per week, per hour, whatever that is. That's the reason we did it that way. One thing that you will notice is that those energy readings are down to the 8th decimal place. That was done for a reason. Those are real numbers right out of the registry, or right out of the registers from the chip. We decided to put in all the information, every bit of information coming from the chip that there is, to eliminate any rounding errors. For large amounts of energy consumption, those small numbers, the lower end numbers really don't mean a whole lot, but we would rather err on the side of caution, give you everything so that there's no rounding errors when you're doing your filtering. So just a note on statistics. The UX120-018 uses a fixed non-adjustable statistic sampling rate of 16.67 milliseconds, or once per cycle. That means if you select min, max, or average, the value that's recorded in the data set is derived from the number of single sample cycles per interval. For example, if you selected a 1-minute logging interval and you selected your maximum statistic, that would be based on a maximum number of samples of 3,600, 60 hertz times 60 seconds. For a 5-minute interval, it's based on 18,000 samples, 60 hertz times 300 seconds. Again, that's non-adjustable. That is the sampling rate. So we're going to talk just briefly about the different screens on the plug load logger. Right now we're on the main screen, or screen number 1. Again, you can see voltage is in the upper left, amperage is in the upper right, power in watts is in the lower left, and energy consumption in watt hours is in the lower right. This is screen number 1. And the logger is right now in meter mode, which means it hasn't been launched in HOBOware. And we can tell by right here it says meter. When we launch the logger in HOBOware, that changes to logging. And then we know that it is indeed launched and logging. The other thing you can see here is these two little boxes are actually pages. So you can see that we're on the first page. If we click on the next button, it will take us to the second page, and that's where that changes. And here we can see we have volt amps, your apparent power, and your power factor displayed here. Now, if we had statistics selected, here we have maximum statistics selected. This would be, it would be considered page 1, but it says max. And these are the maximum values that were detected since the logger was launched. If you press and hold the next clear button, these will be reset. And the next time it refreshes, it will record the next highest maximum number. And that's at a 1-second sampling rate, refresh rate, sorry. So again, you click clear, press and hold the clear button to reset those. Same for minimum. Same idea. This is minimum statistics. It says minimum. We don't display average statistics on the LCD, but we do log them. This device has your standard flexible start, stop, and restart options. Again, you can start it immediately. It'll start. You can have it start at the next logging interval. You can have it start on a push button trigger, or you can have it start automatically on a specific date and time, which is what we used to call delayed start. Now we just say on specific date and time. To stop the logger, you can have it stop when the memory fills, which is like the standard the old U12s used to do. You can wrap it. In other words, if you say never, once the logger memory fills up, it will begin to overwrite the old data again. You can stop it on a push button trigger, or you can have it stop automatically at some specific future time and date. You can also have it resume logging on a push button trigger if you wish. One of the really nice features of this logger is it's very simple to set up and to launch. Here is the launch screen from the plug load logger in HOBOware. You can see your standard HOBOware. Again, we really wanted to make this just like regular any other HOBO, so it's not foreign to anyone. So you can put in your description, tells you how many times it was deployed, what the battery level is, and then you just check off the measurements that you wish. Again, your raw measurements are volts, amps, watts, watt hours, VA, or power factor. You can also log the battery if you want to. The other thing too is the statistics checkboxes are right there for you. If you wanted to log max, min, or average, you just select them there. You don't have to go to a different screen. The only time you'd have to go to a different screen is if you wanted to pre-filter any data. In other words, if you wanted to say, okay, I want to filter, I want to know what my total active energy is for a specific time frame, you could apply that filter ahead of time. The rest of the deployment information is pretty straightforward. It's just like the rest of our UX120 products, very similar. As far as the plot setup screen, when you read out your data or when you open a data file, again, very straightforward. One of the things that I like to point out is down at the bottom of the screen where you see data assistance, there are no data assistants available. In other words, you don't have to post-process your data. You get the data. As soon as you read it out and plot the data, you've got it. So you can see these are all the channel. You have the ability to select or deselect any of the channels that you had enabled when you launched the logger. You can also display under active energy. You see there's a drop down where it says watt hours. If you click that drop down, you can switch that to kilowatt hours if you wanted to see it displayed like that. If you were logging a high enough energy consumption to actually make that worthwhile. Down at the bottom of the screen where it says select internal logger events to plot, you can see that there's an internal event called line loss. Line loss and line resume, basically what it does is it puts a little flag in the data set if you lose power during the deployment. And so it basically ticks off the exact time and date when you lose your power and when it came back on again. And again, because you're battery powered, you don't have to worry about losing any data. And here's a sample data file that I really like. It's from a television set that one of our salespeople was monitoring. And again, you can see he was monitoring RMS voltage, current, active power, energy consumption, VA, and power factor. So he was basically monitoring everything. And again, you can see here where we do have the 8 points of precision here on the watt hours. Those are real numbers. Again, when you start getting up into the higher numbers of energy consumption, the smaller numbers mean less and less, but we don't really have an elegant way to truncate that just yet in HOBOware, so we decided to leave it there so that when you do your totalization, your number is as accurate as we can possibly provide it. So one of the things here, this is a little graphic that I borrowed from one of our customers. A typical office space, the kind of measurements that you would monitoring, or if you were monitoring energy consumption in an office space, and what we would suggest for products. In the past, we had a solution for going into the main electric panel. We had a solution for occupancy monitoring, but we didn't have anything for plug load here. So nowadays we have the ability we can put a plug load logger on our power strip. We can use the HOBO power logging system to monitor the mains, and then we can stick a UX120-018 light occupancy logger here, and we can log all of this data and combine it all into one data file very, very easily. This is and to highlight that functionality a little bit, this was a study I did actually in my own cubicle. What I did is I took my laptop and my monitors and everything that plugs in, put them into one power strip and put them through my plug load logger. Now, my laptop was set to go to sleep and shut the monitors off after 15 minutes. So what you see here is you see my energy consumption here. You can see when I went off to a meeting, when I went off to lunch, when I came back. This is when I went home for the evening. So this is my standby power. And then when I came back in the morning, my various meetings, my lunch period, and then going home again, etc. So the other thing that I did is in this cubicle, I put a UX90 HOBO-005 occupancy logger in the same place. Now I had it for a lockout for 5 minutes, so you'll see a little different occupancy data. But what you can do is it's very easy to combine these two files together and get an idea of occupancy versus energy consumption in this same space. So you can see here when I was walking away, coming back, etc., and then when I was actually here doing a little work. And these spikes here actually correlate to the time when the cleaning crew came through in the evening and vacuumed the space and cleaned out the trash barrels, etc. So this is very easy to combine these two data files together. You just basically open one of them and then say merge data files, and then select the file to merge, stick them together, and then save them as a HOBO project file. You just say File, Save Project. Very easy to do. I actually created a screen capture video that describes how to do this, and it's on YouTube under HOBO Data Logger How-Tos. So we put together a few FAQs based on some feedback we got from beta testers and some other folks. So a typical question is, how do I know it's accurate? Well, as we said before, each logger has all of its measurement channels calibrated to an ANSI C1220 0.5% traceable device. It's a digital energy power meter, and it verifies the accuracy of every channel. And those calibration coefficients are written into the logger's memory. A little review of how meter mode works. If the logger's not launched, as soon as it's plugged in to an outlet and then with a load plugged in, it begins to display all the measurements on the LCD, and it displays the word meter. Once the logger's launched, the word meter is replaced by logging. If you want to go back into meter mode after you're logging, just read out the data from the logger using HOBOware and select when HOBOware will say the logger's currently logging, do you want to stop it? You just say stop and then offload the data, and then the logger will revert back to meter mode as long as it's still plugged into the outlet and to the load. So it's pretty easy to use. Another common question, what happens if the batteries die during a deployment? Well, the logger will continue logging as long as it's still connected to the AC power. We do suggest that you make an attempt to stop the logger and offload it with HOBOware before you disconnect it from the AC power. You're probably okay if you disconnect it, but if you catch it just as it's trying to make a measurement, you could have some issues. That's the reason we put batteries in these things to begin with. AAA batteries are very cheap, they're very easy to change, and again, it gives you the displayed battery life right on the LCD and in HOBOware, so there shouldn't be any excuse for letting it run until the batteries die, but things happen, we understand that. The other question that came up from one of my salespeople was, can I log data to memory without the batteries installed? Well, it will work. However, we don't advise it because, again, if you have a power outage, somebody unplugs it, and it's in the middle of a write cycle, you could have issues with your data. There's a lot of safeguards built into these devices that will prevent that kind of thing, but it's just not advisable. Another question that just came up yesterday, what countries will this design support right now with this North American configuration? Well, I did a little research and I'm amazed at how many countries it will support actually. All of these countries use between 100 and 130 volts AC, and they use the type A and B outlets. So it will work in all of these different countries, including countries I never thought of, like Venezuela and Taiwan, places like that. We included some definitions just for our folks if they had any questions about what do we mean by true RMS current or voltage. Again, it's root mean square. It's the real or effective value of the AC voltage or current, basically DC equivalent. Basic electronics. Active energy, again, that's how much energy your device is using, power over a period of time, if you will. A watt hour is Basically, it's 1 watt over 1 hour period of time. A kilowatt hour is the unit of energy equal to 1,000 watt hours. Pretty simple. Active power in watts is the capacity for the circuit for performing work. Again, that's just the typical power definition. And then VA is the product between current and voltage. Again, if you had a DC circuit and you combine voltage and current, that gives you your power. Obviously, with AC, you got a few other things going on with power factor, etc. So VA is just an apparent number. And then power factor is a ratio between the real and active power. Again, it's an AC thing. It's defined as a dimensionless number between -1 and +1, but for this product we're suppressing a negative power factor because it causes a lot of confusion for people. So we're suppressing negative power factor. Our power factor is displayed as between 0 and 1. Just a quick review of our existing UX product line. Our UX100 temp and humidity loggers. We have ones that do temperature only, temperature and humidity, combined a couple of different configurations. We do have a thermocouple UX100 as well, single channel thermocouple logger. We have our UX90 runtime series, which can do light on off, occupancy, motor on off, state, pulse, or event type logging. Our other UX120s, we have a 4-channel analog device that can take a myriad of different types of analog inputs, temperature, AC current, etc. We have a 4-channel thermocouple logger that can take up to 4 different types of thermocouples. We support JKTSR, and there's quite a few others that we support. And we also have a UX120-018 that's a 4-channel pulse event, state, and runtime logger. Okay. I'm going to look through, see if we have any questions from the audience. 220, it will not work on 220. This is designed for 120 only. Right now, we're going to come up with a 220 version. We would love to hear about what your applications might be for 220. If it's a US 220 application, or perhaps if it's a 220 application for an international type application, we would be very interested in hearing about what your application might be. Let's stroll through a few more questions here. Yes, I see one of the questions is, oh, wait a minute here, let's see. Sorry, my window is very small. It asks, can a power strip be connected to this device to monitor, to log the entire connected load? Absolutely, yes. That's a very good way of doing that for an office type environment or cubicle. If you, I have a question that says, what happens if you overload it, if you go to 18 amps? It's not going to hurt the device at all, but if you're on a 15 amp circuit breaker, it'll trip that breaker. It won't damage the unit at all. Maximum inrush current, I believe we're just saying 15 amps. I don't know what the maximum would be, but it's certainly not going to damage anything, but it is designed for 15 amp loads. Yeah, we have a question. It says, early screen shows it that it does true RMS power only measures 1 sample. That's true. The thing is the chip is actually sampling at 6.99 kilohertz. So that's the value that you see. The statistical value is based on 1 cycle, but the displayed data and the logged data is based on a 6.99 kilohertz sampling rate, which for true RMS, I believe you need something like 16 samples per cycle, something like that. So this gives you more than enough resolution to get true RMS out of your log data. Another question someone asks, when do you plan on increase 1800 watt capacity to say 5,000 watts? We don't have that in our back pockets just yet. We would be very interested to hear that. We're going to include this as what we call a new product request from you. Right now, this device is, because of its size and cost, it's limited to that size, and I'd be very interested to hear more about what kind of application you would need 5,000 watts for. We have another question. It says, can you talk about the occupancy logger deployment? Where did you place it to capture your occupancy? The occupancy logger that I was using, I had it in my cubicle. We work in cubicles that are about 8 feet by 6 feet, and I had it on my desk facing me, so that it was very, very close to my physical location. The reason I did that, I've tried having it off to the side, and it was picking up people walking by my cubicle, because it does have a, I think it's a 5-meter length of field of vision. So I had to have it pretty localized to me so I didn't get false occupancy readings. Another question, do we have a distributor program? Yes, we do. On our website, there's a list of our distributors, both internationally and domestically. If you're interested in becoming a distributor or want to know more about our distributors network, you can contact us at sales@onsetcomp.com. Another question, can you change batteries while it is plugged into plugged into the AC power? Good question. Absolutely not. And it's designed so that you cannot take it apart if you have the outlet plugged in. That is a safety concern. Another question, are there any components to protect against overcurrent? Yes, there's an internal fuse, but that's to protect the logger itself. It does not have a circuit breaker to protect the circuit. The circuit is protected by the breaker that it's controlling that circuit. And I do have a comment from someone who's in Botswana who says they're all 220. Yes, thank you very much. We are familiar with that. We will be looking at different types of international configurations moving forward. Also, just a suggestion that we have a 208 version for ultra-low freezers in labs. Absolutely, we will be looking at that as well. And we will be logging all of these comments as what we call new product requests so that we can determine what the next configuration might be. Another question, just a comment, like to see this in 208 for monitoring large equipment, energy use, like a forklift, chargers, and servers. Yep, great, thank you. We will be looking at it. Question, does the outlet you plug into have to be a 3-prong grounded outlet? No, it will work on a 2-prong. That's what they call a type A outlet. It will work on that. Just a question, do you have any similar meters for larger equipment, rooftop units, etc.? We do have some other applications, not for plug-in type, but for monitoring at the panel level, and you can contact our sales folks. Again, all of these questions are being logged so that our sales applications people can get back to you and kind of talk you through your applications. Another question, will it catch spikes in power from the utility side? Depending on what if you have statistics, you might. Again, it's not really a power quality analyzer type device. One thing that we did was I was logging a marketing printer, and I had minimum and maximum voltage selected, the statistics, and I actually found that we were getting a huge sag in voltage when the thing started to print, and it was caused because the printer was on an extension cord. So that was a really one of those real world type cases where we really found out an interesting issue based on the logger's data. Again, it's not really a power quality analyzer. I got another question from someone who says 1 watt for PC sleep. Again, oops, wait a minute. For PC sleep mode monitoring, 20 watts on, 2 watts sleep, ½ watt off. It'll be able to differentiate between 2 and 1, right? It's not going to read down a ½ watt. Yeah, another question, are these meant for indoor use only? Yes. I don't foresee an outdoor version, but I would be very interested to hear more about what type of application you would be monitoring plug type loads outdoors. We would be interested to talk to you about it. Another question about 220, 240, not yet. We will be looking at this very closely. That's why this input is so very valuable, and I really do appreciate that input. We're going to be logging this and talking about what the next step might be. All right, that's it. Well, thank you so much, everyone, for joining us today. Just a couple more points here. We're going to talk about, for training material, you can go on YouTube, HOBO Data Loggers, or go on onsetcomp.com and go to Learning and White Papers. There's plenty of training information. There's going to be more about the plug load logger moving forward. Questions about the training, you can contact me. My name's Herman Gustafson. I'm Product Marketing Engineer. There's my direct phone number and my email address. If you need technical support when you take the delivery on this, or if you're moving forward with any kind of other projects, give us a call or contact our tech support at loggerhelp@onsetcomp.com. And for some of these other applications, I really strongly suggest that you contact our sales folks at sales@onsetcomp.com to kind of so they can log your comments as new product requests and follow up on any kind of applications you might be involved in. Thank you so much for joining us, everyone. Have a great rest of your day. Take care.